Welcome to the E-Academy. This is a new episode dedicated to the ABAX 2 system. So far, we have shown you how to register wireless devices to the ACU220 controller working as a universal module of wireless devices. We have also discussed some information and indications displayed in the ABAX 2 soft program. Today I will continue this topic. I will use the previously configured devices and 3 new APT200 key fobs. Connection between the program and the ACU220 is active. I click Read Data to download information from the module and choose the Status tab. In the lower table at each of the devices registered in the system there are indicators of radio signal strength. They are necessary to determine how to optimally arrange components of the wireless system in the premises. They determine the strength of the signal received from a given device by the ACU module, as well as the strength of the signal received by the indicated device from the ACU module. By default, they are presented as a percentage. Double-click on them to switch over the indication to power units. How can these indications be interpreted? The most important rule is that indications of the signal strength at a given device in both columns must not be lower than 40%. Otherwise, the planned installation location of the wireless device must be changed and the 2 indicators checked again. The relationship between the strength and the quality of the signal can be seen in the table. Generally, it should be assumed that the higher the signal strength, the better the quality of the radio communication will be. Sometimes it is enough to move the given detector signaling device or module 10 or 20 centimeters to significantly improve the signal quality. You should not install the device permanently until you get optimal values in the RSSI columns. What can affect the radio signal strength in a given location, for example, in the premises where the wireless system is to be installed? First, the distance between the controller and the device. It should be remembered that the radio communication range of the ABAX 2 devices is always determined in the so-called open area. It allows you to compare the catalogue specifications of wireless devices of various systems available on the market. Inside buildings or urbanized area, the propagation of a radio signal is affected by many factors, such as the thickness of walls and ceilings, the number, the type and humidity of the material in which they are made. You need to keep in mind that thick walls with low humidity will not suppress the radio signal as much as a wall that is thinner but made of a material having high humidity. Also of importance is the arrangement of reinforcements and other metal elements, such as steel beams, door frames or anti-burglar doors in the construction of the given building. The presence and layout of the low and high current systems as well as the plumbing installations may also be significant. I'm going to go back to the ABAX 2 soft program. Under the device's status table there are 4 buttons. One of them is Graphs. Clicking it will open a new window. Here you can see the current level of the radio signal in each of the 4 868 MHz band channels which are used by the ABAX 2 system. Pink lines represent transmissions sent by the ABAX 2 devices registered in our controller. As you can see, each of these transmissions was sent by the channel which at that moment was the least busy. Using these graphs, we can also check if there are other radio devices working in the channel that might interfere with the communication and what the radio noise level is. If the unwanted radio signals occur and they are comparable or stronger than those from the devices of our wireless system, they will interfere with its operation. This may result in periodic loss of connectivity and increased energy consumption by the wireless devices. Looking at what can be seen by the graphs, you can take into account that at the moment when this E-Academy episode is being recorded, there are almost 200 ABAX 2 devices in the SATEL building that are being constantly tested. Therefore, the level of noise is relatively high. In practice, such situations are extremely rare. Usually the noise level does not exceed 100 dBm. Let's close the graphs window. The Status tab has the Communication History sub-tab. I will go to it now. In the upper part, I select a wireless device to display graphs showing the history of its communication with the controller. Here is one important note. The communication history data is only collected when the program is running. The noise waveform is marked in blue. The light green color is RSSI ACU, that is, the strength of the signal received from the indicated device by the ACU module. The third curve is dark green and marked on the legend as RSSI Dev. This is the waveform of the strength of radio signal received from the controller by the pre-selected device. As you can see, both green waveforms along their entire length are located above the noise level, which means the radio communication should work without interference. It should be noted that the signal strength levels for the indicated wireless device installed in a given location can vary in time, depending on the so-called propagation parameters, for example, weather, including air humidity. It is important that the level graphs marked with green color run above the noise level along their entire length. It is because the transmission parameters may be good during normal operation of the device, but when unfavorable propagation conditions occur, communication with the given device could be disturbed. The waveform graphs would approach or fall below the noise level. Now let's move on to the Key Fobs tab. For now, only one key fob previously registered on the ACU module is visible on the list. In addition to its serial number and name that we can change, for example by entering the user's name, we have 6 fields available for each button or combination of buttons. In each of them we can enter the number of outputs to be controlled by the given button or combination of buttons. The ACU220 module has 8 controllable outputs. I will program the option to control, for example, the outputs out1 to out6. The next column is described as LED. You can specify in it the state of which the ACU220 controller input should be shown on the key fob LEDs. This state will be presented for a few seconds after pressing any key fob button and receiving a response from the ACU module. The first number accounts for the red LED, the second for yellow, and the third for the green one. I will assign them the AR1, AR2 and AR3 inputs respectively. Please remember that the normal state of programmable inputs and outputs can be changed in the Configuration tab. We can also determine the operation time of individual outputs, which will behave as monostable outputs when controlled with the key fobs. The maximum operating time is 99 minutes. For the outputs 2 and 3, I will set the time at 5 and 10 seconds respectively. If we leave the value 0 in the operating time field, each pressing of the key fob button will toggle the state of this output. It will behave like a bistable output. I send the data to the module. To check how the key fob signaling works, in the meantime I connect the out1, 2 and 3 outputs with wires to the inputs having the corresponding numbers. In this way I should receive confirmation of the key fob that individual outputs have been driven. In this case, the ACU module will work as a radio link with confirmation. Pressing the empty circle button will toggle the state of out1 output and therefore also AR1 input. While pressing the empty square button will turn on the out2 output for 5 seconds and violate the AR2 input connected to it. Pressing the triangle button will turn on the out3 output for 10 seconds and will violate the AR3 input. Let's check how it works. I press the empty circle button. The out1 output has been activated. A red LED has signaled the violation of the AR1 input. Now I will use the empty square button. The out2 output has been shortened to ground for 5 seconds, hence the AR2 input will also be violated for such time. The red and orange LEDs have confirmed violation of the AR1 and AR2 inputs. I press the triangle button. The out3 output has been activated for 10 seconds. The red and green LEDs have come on to confirm the violation of the AR1 and AR3 inputs. The next press of the empty circle button should turn off the out1 output. OK, the key fob has acknowledged audibly it received an answer from the controller, but no LED has come on, which means the inputs are not violated. Now I will show you how to quickly register several key fobs by copying settings, that is, without having to manually assign functions to further buttons and LED indicators. I'm going back to the Key Fobs tab. With the key fob already added and configured, I select the template option. To add another key fob, I click on the plus button. Add the serial number of the key fob and press one of its buttons. Choose the number and press OK. As you can see, configuration for this key fob has been copied from the first one marked as template. I change its name. If necessary, I can also change its settings. Now I will check the template option at the newly configured key fob and send data to the controller. To add another key fob, I repeat the procedure. serial number, the number of the list. OK. The configuration was copied from the template, that is, everything has worked as expected. I send the data to the module. Now I go to the Key Fob State tab. At each registered device you can see the assigned name, serial number, battery level, indicator and its voltage. Because the key fobs do not communicate cyclically with the ACU module, the visible indication represents the information that went to the controller during the last communication, that is, after the last use of the given key fob. In the RSSI column, as in the case of other devices, we can check the strength of radio signal received from the key fob by the controller, which means, for example, from which locations the controller by using the key fob will be possible. The point is whether the signal level will be sufficient when using the key fob in different parts of the building or its surroundings. I would like to remind you that the maximum range of radio communication in the open area for the APT200 key fob and the ACU220 module is 1,200 meters. In practice, this distance may be smaller as mentioned at the beginning of this episode. Finally, I will show you how to automatically update the key fob firmware. Well, the firmware version of this copy of APT200 is out of date. In a moment I will register it to the ACU module. The automatic update option is enabled. When the controller detects that the key fob firmware version is older than that currently available, transmission of the new firmware to the key fob will start. The key fob registration proceeds in the same way as before. I send data to the module. Go to the key fob state. In order for the key fob to communicate with the module, I must press one of the buttons. As you can see, the firmware version of this key fob is displayed in orange, which means it is out of date. The automatic update process will start in a moment. In the field given, you can observe its progress as a percentage indication. The key fob signals the update by a rapid flashing of the red LED. When the process is finished, the key fob will emit a short beep and then all three LEDs will flash. Remember that for the update to be successfully carried out, the key fob should always be within the operating range of the controller. However, if it happens that the APT200 is out of range because the user, for example, put it into his pocket and walked away, the update process will be suspended. It will resume automatically as soon as communication between the key fob and the controller is re-established. That is, when the key fob is in range and any button on it is pressed. Automatic update attempts may also be suspended as a result of radio signal interference or when the device being updated has any problems with the power supply. In this situation, a yellow triangle icon with exclamation mark will appear next to the firmware version in the program. To restart the update, you will have to clear the trouble memory and press any button on the key fob. That's it for today. Thank you. I invite you to watch the next episode of the Academy.